Hello everyone. In this video we'll discuss the very simple concept of the errors. Okay, so in the previous video we saw how we came up with the linear regression line. So basically let's say you come up with some linear regression line, okay, and you want to know how good is your estimate, how good is your line. Okay, so basically you have the actual price, actual y values. The predicted price is obtained when you substitute the x values in the equation that you created or you came up with. So, given the actual and predicted prices, the first thing that you have is just the error. What is the error? It is the actual price minus the predicted price. So, 250 minus 265 is minus 15, 110 minus 140 minus 30, 500 minus 480 is 20. Okay, so it is color coded for red being negative errors, 20 being that is yellow being positive errors, and green being 0. Okay, now the issue with using this particular error value is that, as you can see, ultimately the sum of all the error values will be 0. Okay, so therefore we move on to something better, which is the absolute error. Okay, so in this case you take the absolute value of the error. Very simple to understand. So simply you take the absolute value of whatever you have written in this particular column. Okay, so everything is positive over here. Now when you take the sum of the absolute values, okay, when you take the sum of the absolute error column and you divide it by the total number of predictions, number of rows or number of predictions, basically number of data points also you can say, basically number of predictions, that gives you the average of the absolute error or mean absolute error. Mean absolute error, abbreviated as MAE. Okay, so this is mean absolute error. Okay, now similarly we move on to one more variant. Now what is the problem with using absolute values? Mean absolute error treats absolute errors linearly. That is, a change in the error will have a proportional effect on mean absolute error. Okay, this is linearly proportionate. Change in error, for example, if this becomes minus 20, this will become just 20, right? So what we want to do is we want to emphasize or penalize the errors more. So therefore we square the error. So it gets rid of the negative sign as well as it amplifies the magnitude of the error, penalizes the error more. Okay. Another way you can look at it is the calculus. Absolute error, when you try to apply the calculus on this, when you are trying to find the minima of the absolute value, it is difficult because, or impossible even, because absolute value mod of x is not differentiable, right? Whereas x square is differentiable or error square will be easily differentiable. So for these reasons we find the squared error. Once we find the squared error, we find something similar to mean absolute error, that is the mean squared error. Okay, and by your common sense you must have understood what I'll write. You must have predicted what I'll write. This is equal to the sum of the squared errors divided by number of predictions. But now there is a slight problem in this. If you have studied the concept of dimensions, basically the dimensions of the price, in this case it is price, in terms of physics if we say mass or whatever, the dimensions of this are linear dimensions. Like for example, the units of these are, let's say this is in rupees, right? Okay, let's say this price is in 1000 rupees. Okay, so 265,000 or whatever, like in hundreds or thousands. Okay, so basically it is in terms of rupees. but your squared error is in rupees squared. So the unit gets squared in this case, right? So something more meaningful, something in the same dimensions as the original quantity is the square root of MSE. Square root of this is the root mean squared error, RMSE, that is root mean squared error. Okay, so this is the basic simple concept behind all of this. So if we want to complete the calculation in this case, the sum of the absolute errors will be 330 in this case, and sum of the squared errors will be 18700 in this case. So if we find the mean absolute error in this case, it will simply be, okay, it's a different thing. Okay, so in this case, mean absolute error will be 330 divided by 10, which is 33. Mean squared error will be 18700 divided by 10, which is 1870, and this will be the square root of 1870. Again, this is in rupees, this is in rupees, right? We have units, but this will in rupees square. Okay, so now this will again be in rupees, and this comes out as this the unit will again be in rupees. Okay, so that's it for the errors.